Hello, dear GMAT 41's channel members, subscribers and viewers. You are welcome to our physics tutorial. In this video lesson, I'll be teaching you projectile motion. In our previous classes, I already taught you motion along straight line, okay? When we talk about motion along straight line, usually our attention is given to horizontal motion. For example, if I move from this point to this point, that is motion along a straight line. Okay? We also treated motion under gravity, where in that case you look at an object, moving vertically or downward, something like this. It goes up, it returns. That is motion under gravity. So in this video lesson, we want to now look at the type of motion which is not vertical and it is not horizontal. That motion is between vertical and horizontal. Meanwhile, in order to take previous lessons, you can hit the info link above in order to take the tutorial on motion along a straight line and motion under gravity. So you can take the lesson in order to get used to that aspect of motion as we move on into this projectile motion. Like I said, in projectile motion, you are looking at motion along a parabolic path. Yes, that motion is not vertical and that motion is not horizontal. The motion is between the vertical and horizontal, and usually it goes this way. You can watch as I trace. Something like this. Okay, let me make it to lie within this plane. So we'll have something like this. So did you notice? Something like a curve gets to a maximum height and then return back to the horizontal. Such motion is known as projectile motion. So by definition, projectile motion is a motion of an object along a parabolic path. The shape of the direction of the motion is a parabola. And we could say that the trajectory of projectile motion is a parabola. Once again, take a look at it. We have the vertical, we have the horizontal, and then projectile motion, which is motion along a parabolic path, goes like this. So this shape traced is a parabola, something like this. Good. So this is the trajectory of projectile motion. So you can see this highest point is the maximum height of that projectile. You can actually label it to be something like this, okay? So we'll have the maximum height, we use h to represent it. From this point where supposedly we assume you release that projectile, to this point where the projectile hits the projection plane, that is, came back to the horizontal, we call that distance the range of the projectile. This x-axis. We'll have the vertical, of course, y-axis. Then this parabolic path, remember that the projectile is released in this way, so it goes and then it returns. When you release the projectile, you give it an initial velocity, okay, u, which is initial velocity in meter per second. There is an angle here, theta. That's the angle that the parabola makes with what? The horizontal axis. When you release the projectile and it goes this way to the maximum height, it will definitely return back to the projection plane, that is the horizontal level. Just like when you throw a stone or you release a stone from a catapult, it moves and then it gets down. It's even possible for you to throw something like this straight. But when you release something straight this way, it can't keep going straight, alright? It will go up to a point and then fall down. When it is falling, it falls along a parabolic path. It goes this way horizontally, then fall along a curve. It cannot go this way and then just fall once like this. Okay? So at any point in time you release something, once that thing moves, before it gets down, as long as the motion is not clearly vertical. Are you getting me right? So once it's coming down, it's actually going to trace a curve. Horizontal. Now, if the object is to get down, it's going to curve this way and then fall. So you could see the parabola traced from a point like this, that curve. And then if you release maybe at an angle, something like this, alright, it goes up to maximum height and then curves and returns. So such type of motion is known as projectile motion. It is not purely vertical and it is not purely what? Horizontal. It lies between it, which means it will have vertical value and what? Horizontal value. Resolving this velocity, for example, along the vertical, you have something like u sine theta. If you resolve along this horizontal, you have something like u cos theta. Does that make sense, right? That is to say that this velocity has two components, because once you release a projectile along that path, initially as you release it, are you following, right? It has a certain velocity component, like you are sending it to the vertical. Then once it moves, it will now have both vertical and horizontal velocity. So based on that, I'm saying that this velocity you have here can be resolved to have u cos theta, that's velocity in the horizontal direction, have ux here, and then you could also have its value along the vertical, so have uy, which is equal to u sine theta, u sine theta. Alright, these are the two components of this velocity given to that projectile. Now, I said something earlier that when you release a projectile, alright, that object that is undergoing projectile motion is called a projectile. It gets to a point which is the greatest height and then it returns. Now, it takes a certain time for this to happen. It takes what I said, a certain time for this to happen. The time it will take the projectile to get to the maximum height and then return to the projection plane, that's return back to the horizontal. That time is called the time of flight. And we are going to define it as capital T. So you want to take note of that. Capital T, which is known as what? Time of flight. So there are three major quantities we usually deal with when we study projectile motion. Three major quantities. One of them is the time of flight, which I already explained. The time it will take for the projectile to get to the maximum height and then return back to the projection plane. The horizontal is known as the projection plane. And then the maximum height, the greatest height that is reached, attained by the projectile. Then finally we talk about the range, which is the distance from where you release the projectile to the point where the projectile will still land on the ground, on the projection plane. Now we are going to define these three terms one after the other, and then we'll look at their equations, alright? We will define them and then look at their what? Equations. This is the symbol we use for three of them. H for maximum height, R for the range, and capital T for time of flight. Now we are going to define them one after the other. I will start first with the time of flight. What is the time of flight of a projectile? The time of flight of a projectile is the time it takes the projectile to get to the maximum height and then return to the projection plane. That's the definition. The time it takes the projectile to get to maximum height and then what? Return to the projection plane. You release the projectile, it gets to its maximum height and then return back to the projection plane. That time is called the time of flight. Now you notice that the time of flight is made up of two times, right? Because first of all, if you release the projectile, it will get to this maximum height. That is one part of the time of flight. Then you also need another time for the projectile to return, to fall back from that maximum height down to the what? Projection plane, making it the second time in this time of flight. That simply tells us that time of flight is made up of two times. One, the time it will take to move that projectile to the maximum height. And two, the time it will take for the projectile to return back to the projection plane. One interesting thing about these two times I mentioned is that they are equal. And we can use small t to represent it. We can use what? Small t to represent it. So the idea is this, that the time of flight, capital T, is equal to 2 times, which is t plus t, small t plus another small t, giving us 2t. So we could simply say that time of flight, capital T, is equal to 2t. How about we label this as equation, should I call it equation I? Equation what? I. Please take note, that small t, we do not call it time of flight. We don't call it time of flight. Whenever you hear time of flight, it is capital T, which is equal to 2 times small t. And remember, small t is simply the time it takes the projectile to reach the maximum height, or the time it takes the projectile to what? Get down from the maximum height. Now I'm talking about time of flight. That is the total time to go to that maximum height and to return. So time of flight is equal to 2 times that small t. That being the case, we want to get the value of this small t. We want to get the value of this what? Small t. And how do we obtain the value of this small t? The value is actually obtained from the first equation of motion. Remember, from the first equation of motion, we have v to be equal to u plus at. Now, under motion, under gravity, when I treated that, motion under gravity, if you release an object going up, we have it as v equal to u minus gt. G now represents acceleration a. At maximum height, v is equal to 0. So now I have the initial velocity there. If you work on that, we will have that, I'm going to use the word recall, that t is equal to u all over g. That's what we are going to get, because in that equation, v will be taken as 0 at maximum height. So that is the value of small t. Now, resolving that small t in the vertical, because you are releasing that thing to a certain height, you have u sine theta. Therefore means that t is equal to u sine theta if you consider the angle at which the projectile was released. We use theta for it. I showed you that vertical component is equal to u sine theta. So we're going to divide this by what? G. So you want to take note of this equation. Let's call it equation II. And that is interesting. The time it will take the projectile to reach maximum height and the time it will take the projectile to get down from the maximum height, which I told you those two times are the same. That time is equal to u sine theta over g. It can simply be u over g if maybe the object is projected vertically upward. But if you project the object at an angle, which is the idea of projectile motion, you must respect that given angle. In that case, the velocity u, you are going to work on it using this vertical component, u sine theta, divided by g. We can now conclude that the time of flight, which is capital T, is now equal to, remember, from equation I, it is 2 times small t. So it's going to be 2 times this small t here. The small t is what? U sine theta divided by what? G. Let's take this as equation 1. I will asterisk it, and that is the formula for solving the time of flight. Now, if theta, the angle of projection, is equal to 90 degrees, the idea is that the object will be released vertically upward like this, straight on. Okay? It will not go at an angle. It will go up straight if theta is equal to 90 degrees. And in that case, if theta is equal to 90 degrees, that motion will now return you back to motion under gravity, because that one is purely vertical. Sine 90 will give you 1. 1 times 2u will give you 2u divided by what? G. It's okay. I guess you understand this. That's how we obtain that equation that you have there. We are going to quickly define the maximum height and the range of a projectile. I'll simply write the equation for you. Those equations are actually obtained from equation of motion under gravity, respecting equation of uniformly accelerated motion. You know, the first equation of motion, the second equation of motion, and the third equation of motion. Those equations are the equation we use in obtaining these. Now let us define maximum height, h. Maximum height. Maximum height is defined as the greatest height attained, reached by a projectile. What is the highest point that a projectile reached before coming down? That greatest height is what we refer to as the maximum height of a projectile. And what is the formula for the maximum height of a projectile, h? The maximum height of a projectile is given as u squared sine squared theta, then divided by 2g. It's actually obtained from the third equation of motion. But in getting this sine square theta, I'd like to give you a little hint, even though I would not prove it in this video lesson because it's not necessary for now. We use the knowledge of trigonometry, trigonometric identity, to actually analyze that. The concept of further mathematics or engineering mathematics can help you to get that idea. But you don't need it for now. And that is why I just wrote that equation there. So we take this, equation 2 asterisk. This is the formula for calculating maximum height. If you come over here, this sine squared theta, how do you analyze it? Find the value of sine theta first. Anything you get, you square it. So permit me to rewrite this somehow. Please take note. Sine squared theta is the same as sine theta. Anything you get, you square it. That's the meaning. Square sine theta, that's the meaning of that thing, right? This sine theta, then all squared. We actually read it as square sine theta. Now we are going to define the third parameter, which is the range. The range. What is the range of a projectile? Just like you can see, it is a distance. So the range of a projectile is defined as the horizontal distance from the point of projection to the point where the projectile lands on the projection plane, where the projectile hits the projection plane. So if I release the projectile, say from this point, and it goes this way, are you following, right? Then it lands here. The distance from this point where I release the projectile to the point where the projectile hits the projection plane, that horizontal distance is what we call the what? Range. And mathematically, the formula for range is given as square root of u, then sine 2 theta divided by g. This is the formula for calculating the range of a projectile. Please, you want to take note of the difference between this formula and the maximum height formula, the numerator. In the maximum height, you have square sine theta. How do we evaluate it? You first have to get the value of sine theta. Anything you get, you square it. That is in maximum height. When you talk about sine 2 theta under range, to obtain sine 2 theta, in this case, you will multiply theta by 2 first. Let us assume that theta is 15 degrees. That angle of projection is 15 degrees. Now to evaluate sine 2 theta, you will first do 2 times 15. You get 30. Then evaluate sine 30 before you proceed in solving. Okay? That's how we work on this. These two equations there, you have the equation 2 asterisk and 3 asterisk. And like I said, these are the 3 major formulas you need when dealing with projectile. Does that make sense? Now, I want you to take note of something, please. This range is actually distance. And we know that there is a relationship between distance, time, and speed of velocity. Speed is equal to distance over time. So we can actually relate this range to this velocity and the time of flight. Okay, let me find a place here and then write notes. You want to take note of this equation, is that okay? That range is equal to the velocity given multiplied by time. You also want to take note of this equation. Let me call it equation 3a asterisk. Because it's actually a form of equation 3 asterisk. The only thing now is that we have introduced this time of flight. Because we know that distance is speed times time. Range is distance, so it's going to be speed, velocity times time. But the time we use here is the bigger time, the time of flight. Total time it will take the projectile to reach maximum height and return. So that is pretty much about the basic concept of projectile motion, and of course, what most exam bodies really expect you to know about projectile motion. I'll quickly give you some examples of projectile. I follow it right. A bullet fired from a gun is an example of projectile motion. And in that case, that bullet is called a projectile. So bullets released from a gun is an example of projectile. What about a stone that is being thrown or released from a catapult? It is also an example of a projectile. That motion of that stone is projectile motion. What about the motion of a ping pong ball? Alright, your table tennis, right? Can you play table tennis? I'm a professional player in it. Don't mind me. I really am very good at playing table tennis. Want to find out one day, just call me for it and I will defeat you. Don't try. Okay, that motion of that tennis ball, alright, when you're playing it. Can feel me, right? Good. Just smash you like. You understand what I mean by that. And you notice that the motion of the ball, it moves in a curved path like this, okay? That motion is also projectile motion. So our ping pong ball is an example of a projectile. Alright guys, this is cool, right? Now we're going to move on to the calculations on projectile motion. If you are yet to subscribe to the GMAT41's channel, please hit the subscription button, turn on the notification bell and personalize your subscription so that you can follow up with the GMAT41's updates, right? You can actually become channel members as well too in order to join our learning community fully. To do this, below this video lesson, you have the join tab there. Just click on that join tab, select whichever of the GMAT41's package that is convenient for you. Support this channel so that we can continue growing, right? And then give you the best as you deserve. Now, come along with me, let's move on to the next focus of this projectile, which is calculations. To do that, click on this info link. Come along with me, let's look at the calculations on projectile motion.